In this example, we have a horizontal force that is pushing on a 29 kilogram block. The force is 250 newtons and it is horizontal. The inclined plane has an angle of 27 degrees, and the block is moving up the ramp at a constant speed. That's important, constant speed. And we are supposed to find the magnitude of the normal force and also the coefficient of kinetic friction. Alright, so since it's moving at constant speed, we know that there can't be any net force, that the forces have to balance out, and our net force has to be zero in both the direction perpendicular to the plane and parallel to the plane. So the sum of all the forces in either direction has to be equal to zero, because constant speed means acceleration equals to zero, and F equals ma, so if a is zero, then the force is zero. So let's do a free body diagram. So we'll start, we've got our weight down, that's mg, and we'll break that up into components parallel and perpendicular to the plane. So that's the component parallel to the plane, that's the component perpendicular to the plane. Since the weight side of this triangle is parallel to the back of this triangle, the top angle of the triangle and the angle right here are congruent. Those two angles are congruent. And then this is a right angle, and this is a right angle, and so the bottom angles are congruent, so this is also 27 degrees. So if this is 27 degrees, and this is mg, then this side is mg cosine 27 degrees, and this side is mg sine 27 degrees, and inclined planes always work that way. Okay, now let's take a look at, I said I was going to do a free body diagram, and instead I'm just breaking forces up in components. We'll get to the free body diagram in a minute. So we need to break this horizontal force also up into components parallel and perpendicular to the plane, because our motion is in the plane of the inclined plane, and so that is the direction we need to be for one of our axes. So we'll take this horizontal force and break it up into components perpendicular to the plane and parallel to the plane. Now, if we look at the two triangles we have here, in this instance, the angle that's congruent to the 27 degrees is this angle right there. You can see that from geometry. If that's our inclined plane, and here's our horizontal force right there, then we've got this force, or this line is parallel to this line, and then this angle and this angle are alternate interior, if you remember from geometry. This force was 250 newtons, and so this side is 250 cosine 27 newtons, and this side is 250 sine 27 newtons. Okay, so we've broken those forces up into components. Now let's take a look at our total free body diagram, make sure we have all of the forces that are acting on this box. So we have the weight down, that's mg. We have this force, this applied force of 250 newtons. We also will have a normal force perpendicular to the plane, and our motion is up the plane. We know we have friction. Friction has to be opposite the direction of motion. The motion is up the plane, so our kinetic friction, because it's moving, has to be down the plane, and so that is our kinetic friction down the plane. So now let's take a look at the sum of our forces perpendicular to the plane. So this is perpendicular to the plane. So perpendicular. We have the component of gravity that's going down is mg cosine 27. the component of the horizontal force was also going down, and that was 250 sine 27 degrees. And then we also have our normal force. And those have to add together to equal to 0 because there is no motion perpendicular to the plane. And then I just made the normal force in the positive direction. That one's going up perpendicular to the plane, the other two are going down. So our normal force is going to be m, which is 29 times 9.8 cosine 27 degrees plus 250 sine 27 degrees, and that is 367 newtons. So that is our normal force. Now to find the coefficient of friction, we know parallel to the plane, we have our component of gravity, which is going down, so that I'll call that minus mg sine 27. And then we had our component of the horizontal force that was going up the plane, that'll be plus 250 cosine 27. And then we're going up the plane, so friction is going down the plane, so minus the force of friction down the plane. It's moving at a constant speed. It's moving at a constant speed, so that means our net force is 0. Now, what is the frictional force? The frictional force will be the coefficient of kinetic friction times the normal force. And luckily, we just found the normal force right here. So now we have everything we need to plug in. So that's minus, I believe it was 29 kilograms times 9.8 meters per second squared sine 27 plus 250 cosine 27 minus mu k times 367 equals 0. So I will have on this side if I combine these two, I get 93.7, and I'll take the mu k times 367 to the other side, divide both sides by 367, and I get 0.26.